So today's conversation is going to be, go accordingly to the plan. We'll talk about operator overloading. Essentially, how do you define your own operators for your classes? And then the next milestone will be the conversation about inheritance at some point. And we can actually switch back to look more at graphics and graphical applications. So, inheritance is greatly related to what we do with the graphical packages. So that should already bring in back the graphics, the topics that related to a graphical user interface. But the operator overloading is something that we need to look at and consider some examples with that. So I'm not sure if I could. I'd like to. Maybe I'll think about a small homework assignment that's related to operator overloading. So we'll see. We'll see how this goes. So the presentation is operator overloading, and basically the idea is this. The idea is this. We know how to create classes. We know that we can define the behavior of these classes, what they do, what kind of data is preserved by each class, each instance of the class. But then sometimes it's convenient, or it might be convenient, to actually have, for example, right now on this page, what I show here is that maybe point is a class that we define, and we can say point 1 and point 2 and start using them. But could we use simple comparison operator like equal equal, similar to how we compare compare integers? Could we compare points? Sure. Point could encapsulate data such as coordinates, so we can verify that coordinates are the same. We can also maybe assign some color attributes to our points, and compare. In addition to that, see if the color assigned to a particular point, if that's related to a graphical display, is also the same. So it's completely legit to to be able to compare points. An alternative would be something like, let's see if I can quickly start a new project, and so we still could use a lot of demonstration today. So this will be overloading, I guess. We'll name it overloading. All right, that's that. Add a source file. We probably need IO stream just to show something on the screen. Okay, so the usual stuff. So we trying to demonstrate something related to the idea of overloaded operators, otherwise operators defined for your specific class. But an alternative to this would be what? Would be, say, point. We can say class point, define class point. Somewhere here, we should probably start using header file pretty soon, but right now it's just a quick demonstration. Public, maybe Boolean, or some sort of an integer, I don't know, compare this point to another point. We could use point reference other, right? And in this function we could just compare 2 points and eventually return something back, right? So if we say point pt1 and point pt2, something like that, we can say if pt1 dot compare, right, dot compare to another point, which is pt2, then do something, right? So we can say, compare. We could define compare is that we can say return -1 if less, right? Return 0 if equal, and return +1 if greater. So you get the idea. Some way of comparing them, whatever the meaning is, who knows, right? So and then the alternative is this syntax, right? But if we could just replace compare with less in the form of if point 1 is less than point 2, right? Wouldn't you say this is a nicer way of doing things? And similarly, if we could say if greater or equal, so you get the idea. This may be a very attractive alternative to compare, right? Because you have to, compare is okay, but look, you have to be concerned with some situations which you have to analyze and return values and so forth, whereas here you just get the condition, test it, and move on, right? And so forth. So this is much more attractive proposition, especially for classes that have the look and feel, which is a look and feel of a numeric class. Okay, so fine. So with that in mind, we should say up front that everything in C++ is a function or a variable or piece of data sitting in memory, because the two building blocks in C and C++ are these two: the data variables and functions. However, if operators somehow we were able to find a way to redefine, then there will be just syntactical sugar replacing function calls. So the operators, if they're overloaded as functions. So overloaded operator is a function defined somewhere in our class or as a free function, but using references to our class. So what kinds of operators are available for overloading? Numerical, typical, arithmetic, plus, minus. By the way, there are unary and binary pluses and minuses, like negation or subtraction, multiplication, division, increments, decrements, all this. Comparisons, we just talked about this, greater or equal, and so forth. Structural would be, recall how string allows you to, when we were talking about strings, if I say include string, for the sake of simplicity here. So if in my main program I said something like this, string str, right, and I can even say hello to provide an initial value. There is a constructor that takes cstring, in the string class. So then I could modify individual characters by using index notation, such as this, like string 0 character, change this to say lowercase character, right? So something like that, and it'll work because in C++, the subscripting or index is actually an operator, and it can be overloaded. And of course, it's overloaded for a string, for standard library string. So we will learn how to do it on our own for our own classes. So this semantic will become available for our own classes. All right.